Okay, so we have our second example here for using this fundamental theorem of algebra to determine what the actual equation is of a graph using the factors. First thing I'm going to do here, though, is point out a few things. It's fourth degree, so that means we're going to have four solutions. Okay, so four solutions. So I know x is equal to 1/2, x is equal to -1, and x is equal to 3i. Well, complex conjugate theorem says that if 3i is a solution, so is -3i. So there are my four solutions. The one thing that I'm going to do here, though, is I'm going to take this right here because of the fraction, actually going to work with it to make it easier. If I multiply both sides by 2, so I'm basically trying to cancel out and get 0 on the one side. So that leaves me with 1, and then I get 2x minus 1 is equal to 0. So that's what it was before I got to the x is equal to 1/2. So I'm just getting rid of the fraction. So I basically multiply both sides by 2, and that gets rid of the fraction, right? And then move the 1 over, and that gives me my factor. So with what I've done here, and including the other factors that I have at the top, the other one is working with the conjugates. So I want to work with the conjugates next to try and simplify this a little bit. Now, based on the fact that we got four pieces here, we want to get rid of the imaginary solution. So I know I have x minus 3i, x plus 3i. That conjugate idea says that all I have to do is multiply the x's together and then the 3i's together. So working with conjugates and distribution. I squared is equal to -1, so this guy is -1, that gives me x squared plus 9. So now I got this piece, and this piece, and these guys are all my factors. So I got the two solutions here, the one solution with the -1. Sorry, let me use the highlighter here. I got two solutions because of the square. I got one here and one here. That's a total of 4. I'm going to start putting this guy together. So I got my factors. I'm going to list those out first. X plus 1, 2x minus 1, and the x squared plus 9. That comes from here. Now I know that there's going to be some sort of coefficient in front, and when I plug in 0, I'm going to get 9. So I'm going to go ahead, I got my a, right? I don't know what that is, but I do know that if I plug in 0 for x, go ahead and write this all out, it's going to equal 9. So I got a times 1, -1, 9. Nice not to have those imaginary numbers in there now. Makes it easier to work with. So I have a negative 9a is equal to 9, so a is equal to -1. So now I can use this piece and write my solution. I got -1 times x plus 1. I just relist my factors. And there is my final solution.